morning, financial algebra. This is a longer section. We're going to be covering a lot of review from Algebra 1, actually. So this is on expense and revenue functions for businesses. Now, expense graphs are always linear, which means that the graph is the shape of a line. So it either usually looks like this or this, and would follow the y equals mx plus b. Revenue, however, is nonlinear. And it is actually going to be its second degree, which we call a quadratic. Now it looks like the following: y equals ax squared plus bx plus c. And the graph is called a parabola. And a parabola can either be pointing up, and it's U-shaped, or can be pointing down. Now the graph is pointing up when our a value is positive or greater than 0. It points down when a is less than 0. Also, when it points down, this top point is called my maximum. It's also my vertex. When the graph points up, that is now a minimum, but it's still our vertex. Now, we are going to kind of cover a lot, like I said, and so we're going to jump right in. I apologize, it looks like I got some water on this first problem, and so there's some marks on the graph. So we're going to be looking at the two graphs together. Remember, our expense should be this linear function, and then the parabola is our revenue. So when I'm only producing 0 units, my revenue is really small. And same with our demand. If I'm producing too much, I'm not going to be making that much either. So it's a very fine balance. So we're going to go over, this is similar to a homework problem. So part A, what is the price at which the maximum revenue is attained? So in this case, remember, our maximum is going to be this peak, and we're estimating, right? So I know right here would be my max. And so if I go across, if this is 15,000 and that's 30, then this would be the halfway. So to find halfway, let's see here, 15,000 divided by 2 plus 15,000. So 15,000 divided by 2 plus 15,000. This would be right here, 22,500. So if I'm estimating, I would probably put 20,000. This is close to 20. So we're approximating, right? So I'm going to approximate that is about 19. I'm going to approximate 18,000. Sorry, I'm looking at the wrong part. What price? So this over here is revenue, or your money. They're looking at what price. So if I look below, I marked that they went by 80. So 80, 160, 240. So this would put it at 200. So I'm guessing this is at a price of $180. The maximum, estimate the maximum revenue. So I'm estimating that's 18,000. And then break-even points. There are 2. There's one on the left and one on the right. And all they want for these break-even points is the price. So if I look below here, I would guess that that's halfway, a little less than halfway, which would be 120. So I'm going to guess that is maybe 115. And the price here, I would guess 310. So we are estimating those values. All right, so I'm going to go over something in a parabola. Our vertex formula, and it can be any letter that they're using, is x equals negative b divided by 2a. And so this is how we would find our vertex or max or minimum. So for number 2, in part A, find the maximum revenue for R equals negative 2,000 P squared plus 44,000 P. All right, so they've given me a value for revenue. Now I know that R stands for revenue and P stands for price of product. So if I'm looking for maximum, I'm going to find the vertex using this formula above. But instead of x, I don't have an x, I have a letter P. So P will equal negative 2 times A. Sorry, I reversed it on accident. It'll be negative 1 times our B value divided by 2 times our A value. So the first number in front of P squared this is A. And here is B. So I'm going to substitute that in. I have negative 1 times 44,000 over 2 times A, which is negative 2,000. So that gives me negative 44,000 divided by 2 times negative 2,000. That gives me 11. Now, P equals 11. So we're going to substitute this in to find revenue. Into equation to find revenue. So I'm going to plug this in into R equals negative 2,000 times our price squared plus 44,000 times our price. And we are substituting the price of 11. So if I substitute this in, I get R equals $242,000. Next one. So part B. And part B, I'm going to ask you to find the price at max revenue. So I'm going to go ahead and do both parts just so we get extra practice, but here's our new formula. R equals negative 125 P squared plus 3,200 P. Now, because they're talking about maximum, we're going to use the vertex formula. So P equals negative B divided by 2A. So here, right here is A, right here is B. So the X, we don't have an X, I have P and R. So instead of X comma Y, I have P comma R. So negative times 3,200, that's what this formula is, a negative times your B value, divided by 2 times our A value, which is negative 125. So if I enter that, I got 12.8. Now you'd be done there because P stands for price. So the price would equal $12.80. If you wanted to go further and find revenue, it would be R equals negative 125 times P squared plus 3,200 times P. Remember, P represents the price, which we just found is 12.8. So if you plug that in, I got a max revenue of $20,480. So that is how you would cover something like that. Now, the next part that we are going to do is to go over how to find the zeros of a quadratic. So zeros of a quadratic is the same thing as solutions or roots. All of those words mean the same thing: zeros, solutions, roots. And I can go into why, but I doubt you're that concerned. But there are three ways to find them. The zeros of a quadratic can be found in three ways: factoring, completing the square, and the quadratic formula. Now, we don't have time to go over all three methods. However, one method, which is the fastest, easiest, and works every time, is the quadratic formula. That method is the most simple. And so I'm going to go ahead and record that down. A quadratic formula is used on a quadratic. So if I have it in standard form, the a term should go first, ax squared plus bx plus c. So my quadratic formula looks like the following. You'll notice the negative b, and on the bottom 2a. That's what we just went over, the vertex formula. And I'm just going to add one part, the plus or minus, the square root of b squared minus 4a times a. I don't need parentheses right now, sorry. Times a times c. So based on this, we are going to do our next problem. And it has quite a few pieces. And so let's see if I can get through each piece smoothly. And we are going to use Desmos. So number 3, Geoff's company manufactures customized t-shirts. Each t-shirt costs $2 to print. The fixed are $2,000. So write the expense equation in terms of demand Q. So first, let's write our expense equation, right? So I have expense is going to equal my variable is $2 per product plus my fixed. That's from the last section. This is $2. Each shirt is $2, and then fixed is $2,000. So here's my expense equation. Then they're telling me the demand function. So this is how I determine the balance between supply and demand, right? Remember, the higher the price, the less it's going to be purchased. The lower the price, right, then everybody purchases it. So it's a fine balance. So here is the demand function. So review from 9.4 is how to write an expression in terms of the other. So it says write the expense equation in terms of demand Q. So I'm going to be substituting what Q equals in for Q. And so I will have expense equals 2 times and then negative 1200 P plus 7800 and then plus 2,000. So I'm substituting it, if you'll see it right in here. All right, so I'm going to distribute the 2. So negative 2400 P. Oh, sorry, that should be a Q. I'm like, wait a minute. Sorry. I'm substituting this in for... Oh, hold on. My bad. My part A is just what we just did. Expense equals 2 times Q plus 2,000. Express the expense equation in part A in terms of price. So now I'm substituting E equals 2 times, and I'm substituting in P, which is negative 1200 P plus 7800. And then we're going to distribute. So I get negative 2400 P. 2 times 7800 plus the 2000 gives me positive 17600. So there's my equation. So this equals my expense. Write the revenue function in terms of price. Now, if you'll remember, revenue equals our price times our quantity. So here is our price, and we're going to multiply. Here is our, so our revenue is our price times our quantity. So price times Q, and they told me what Q is up here, so times negative 1200 P plus 7800. And that gives me R equals negative 1200 P squared, because I'm multiplying these, plus 7800 P. Graph the function. So we're going to use Desmos, and we're going to enter it the following. The top one I'm going to enter as y equals negative 2400x plus 17600. I'm doing that because I'm going to graph it on a coordinate plane. And then the bottom, I'm just changing the letters. Y equals negative 1200 x squared plus 7800 x. So that's exactly how I'm going to enter it. Let me open up Desmos. So in Desmos, you're going to enter, you have to do y equals, I know there's a glare. It's really frustrating, but there is a glare for some reason with this camera, no matter how close or how far I put it. I don't know if I can dim my screen. Oh yeah, you can see it better. Y equals negative 2400 x plus 17600, and then I'm going to hit enter, and then I'm going to hit the next equation. Y equals negative 1200 x squared plus 7800 x. Now I can't really see much, so I'm going to go to this little wrench tool, and I'm going to change. I don't have any negative x's, so I'm going to go from 0, I forget what and then to x is price. And then, but y, I'm going to change into the thousands. So I think I went from 0 to 30,000. And now I have this beautiful graph. Now I can see it because I changed what I could see. So here is the graph. Based on our formulas, and they'd like us to identify, well, what price yields the maximum. So here is our, I'm going to put max, and our price. So if I click this maximum, I get, and let me hit that point. If you hit that point, I get $3.25 for a revenue of $12,675. So that's how I'm interpreting this. The 3.25 is X, and that is your Y value. So price of the product and how much revenue you would make. My break-even points, so would be where the two graphs intersect. So if I click here, that first, I'm just looking at the price, so just X. So break-even points, we're just looking at X values. So 2.41, and if I click on this intersection, 6.09. And I should put and. So those are the answers there. Part E, using any of the methods, determine the roots. Well, I'm just going to use Desmos. And I'm looking at the x-intercepts. And so x equals, the graph hits it at 0. And here at 6.5. And this means at these prices, revenue would be $0. That's all those mean. Moving on, we are going to work on finding our roots. So number 4, given the revenue equation of R equals negative 500 P squared plus 30,000 P, which price would yield a higher revenue, $28 or $40? So here is this company's equation, and they're asking what should we label our price for our product? Which would give us more money? Which would make us more money or more revenue? And so to find that, you would simply substitute each end to our revenue equation. So revenue equals negative 500 times our price squared plus 30,000 times our price. And in this first case, I'm going to plug in the price of $28. So using my calculator, negative 500 times 28 squared plus 30,000 times 28. And I get a revenue of almost $500,000, $448,000. Next, I'm now going to substitute in the price of $40. And so now I'm substituting in 40 to see what the revenue is there. Now remember, fixed expenses don't change. And so let's see which price gives us more revenue. This is only $400,000. So the number that is greater would obviously be the first one. So the price of $28 gives us more revenue, probably because more people are going to buy it when it costs $28. So you might think, why would 28 give you more money? Because often when things are really, really expensive, less people buy it. So $28 is a better price, so more people are going to buy it overall. Number 5, find the roots of R equals negative 200 P squared plus 16,000 P. So the fastest way to find roots is to use our quadratic formula. And our quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Hopefully you recognize the first part from our vertex. So a couple things. I don't have a c value. There's nothing out here. So I know that this is A, this is B, and nothing's out here, so this is C. So I'm going to substitute that in, and I'm going to use the letter P instead of X. So P equals negative 16,000, right? A negative B, plus or minus the square root of B squared, so 16,000 squared, minus 4 times A times C, all over 2 times A. So I just plugged A, B, and C in here. So I'm going to simplify this. And I get negative 16,000 plus or minus. On the bottom, 2 times negative 200 is negative 400. But I have to simplify all of this. So the square root of 16,000 squared minus 4 times negative 200 times 0. And I get 16,000. So I have two answers. You're going to enter negative 16,000 plus 16,000 over negative 400 and negative 16,000 minus 16,000 over negative 400. And if you're asking why the two different ones, is because I have two different symbols. One is plus, one is minus. So I put 1 plus, 1 minus. So if you enter this, I get 0. And if you enter this, you should get 80. So the two different roots, or in this case, the two different P, remember P is for price, is $0 and $80. These are our roots, and they mean that at these prices, revenue would equal $0, which makes sense at a price of 0. It means you're not selling it, right? And you're not making any money. But $80, that is saying that that price is so high that no one's going to buy it, and that's why your revenue would be $0. All right, next one. If revenue is R equals negative 100 P squared plus 40,000 P, at what price would the revenue equal 3.750 million? So at what price would I collect that revenue? So the first thing I'm going to do, this is revenue equals this much. So I'm going to plug that in for R. So 3.75 million equals negative 100 P squared plus 40,000 P. Now, if I'm going to solve this, we can make these numbers smaller. I think that would be easier, but if that is too complicated for you, you don't have to. But I'm going to subtract, so this is all on the same side. So I'm going to subtract. And I get 0 equals negative 100 P squared plus 40,000 P minus 3,750,000. Sorry, I'm missing a 0. Now these are big numbers. I don't like to mess with it. But all of these are divisible by $100. So I'm going to take 100 out of each one because it's going to be the same thing. So 40,000 divided by negative 100 is negative 400. This divided by 100 is negative 37,500. And now I have A equals 1, B equals negative 400, and C equals negative 37,500. And so now I can plug that into my equation. So P equals negative B plus or minus the square root of a negative 400 squared, put parentheses around it, minus 4 times A times C, all over 2 times A. So I'm going to simplify this. A negative 400 is 400, plus or minus the square root. I'm going to simplify it inside here. And so I have parentheses, negative 400, parentheses. Notice I put parentheses around it, okay, or just put 400 squared. But know how to enter things in your calculator. Your calculator is only as smart as what you tell it to do, as your fingers. If you enter it incorrectly, it will do it incorrectly. So minus 4 times 1 times negative 37,500. So I get the square root of 310,000. So I'm going to find the square root of that, and I get P equals 400 plus or minus, I think I did something wrong here, hold on. sorry, hold on. This should be a positive. Let me re-enter that. So 400 squared minus 4 times 1 times 37,500, and this is 10,000, and the square root of 10,000 is 100. So one of my answers is 400 plus 100 divided by 2, and one of my answers is 400 minus 100 divided by 2. So this gives me a price of $250, and this gives me a price of $150. So if I price the product at either $250 or $150, I will have a profit of $3.75 million. Last one. Number 7. Revenue can be determined by R equals negative 340p squared plus 37,400p. What is the max price for a revenue of 612,000? So we're asking, what's the most I can charge for this product in order to have a revenue of 612,000? So here's how I'm going to set it up. 612,000 is my revenue, equals negative 340p squared plus 37,400p. And then I'm going to subtract, so I get 0 equals, I'm going to write all of this, but at the end I'm going to put minus 612,000. Now it's up to you. You can try to divide everything by 340, but if you don't want to mess with it, that's fine. Here's your A value, here's your B value, and here's C. So P equals negative B plus or minus the square root of B squared minus 4 times A times C all over 2 times A. And then we're going to simplify that. The first part doesn't change. The bottom 2 times negative 340 is negative 680. But now I'm going to enter all of this. So the square root of 37,400 squared minus 4 times negative 340 times negative 612,123. And I get 23,800. And I'm going to unlock my computer screen. Sorry, I had it on caps lock. Okay. So now I have 2, right? I have negative 37,400 plus 23,800 divided by negative 680. And I have negative 37,400 minus 23,800 divided by negative 680. So if you enter both of these, I get $90 and $20. So which of these is the maximum price I could sell it for? $90. So whether I sell it for $20 or $90, I have the same revenue, and that's because of my fixed expenses. So remember that, and demand and how many people buy it, so it's more complicated than it looks. But that completes this section.